All right, ladies and gentlemen, we're at my next service call. We have 5 central air conditioning systems here, 4 Bosch, 1 Carrier. These are all 5-ton systems, 60,000 BTU systems. That's a Carrier 2-stage 17-SEER system that we installed in 2018, and then the following year after that, fairly large home, as you can imagine. It's got a huge 22 kilowatt air-cooled generator right there by Generac. We have these Generac staging modules. Customers' complaint, family room system, 5 tons. Yeah, you can imagine the size of the family room. Not cool in the way it should. Set for 72, but indoor temperature is hovering between 74 and 75. And this outdoor condenser fan motor is just running slow. I don't really feel much of a discharge temperature coming out of here. We'll get our digital psychrometer and check on that. But this other one, you can feel that heat. And if I take a look at the line set for that one, she's condensing. She's beer can cold. But that one, no bueno. Let me get my digital psychrometer out and take some temperature readings. Ambient and discharge temperature. Oh no, where did it go? It was in the truck on the passenger seat. All right. Let's spin this around a little bit. Yeah, the coin battery's a little bit loose. We have, it looks like almost 62% relative humidity. It looks like 77 degrees, 76.5 degrees. That relative humidity is still climbing. All good. Let's just curious, see what that one is. Nice hot discharge temperature. That's all the heat being extracted from the inside conditioned space, traveling in that refrigerant and being discharged to the out of the condenser. This one over here, wow, it almost feels like it's doing nothing. Wow. 81.5 degrees. Slow dropping. 80. 80.7, 0.6, 0.5. Let's just check our ambient again. Spinning it around. 76 is ambient. So we are discharging something there. Yeah, a little bit. Let's take a look under the hood and let's check our temperatures and pressures. Yeah. Not beer can cold, that's for sure. Just like ambient. Yeah, I'm not too happy with that. I don't know why it's not secure to the insulated line set, that 7/8. I'll have to get some zip ties on there. Let's put that up right there, maybe. All right, I'm going through the SW1 button and going through these parameters, and it looks like we're gonna be undercharged here based on the numbers that I'm seeing. Not good. Let me break out my JB climate class probes and take a look, see what my system's running at. But not good. Hopefully there's not a refrigerant leak here, because that would really suck. Let's turn these on. Let's get out a little crescent wrench, or there. No, where did it go? You know what? It disappeared. It's gone? Really? Not there. Huh. It's got to be here somewhere. Is it down there? There it is. You know what? when others use my tool bag and put things away, it doesn't go back where it belongs, and it pisses me off. Alright. Ow. Hit my elbow on the wall there. Okay. Ow. 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 .61 psi. Whew, man, that sucks. .139 psi and 61 psi. Damn, that sucks. Here's that 5-ton Bosch air handler, and I noticed oil here right away, and then up the line to our filter dryer, which is leaking. Now, for all of you guys out there talking about, oh, it should be outside, not inside. Well, the ones who put it outside, and oh, it should be inside. Well, this filter dryer is leaking right there. There's all the oil. There's the proof. Proof's in the pudding, folks. But well, at least it's not in a coil. So this is a filter dryer replacement and a charge. Hopefully I have enough play on this where I could just pop a new one in the middle. And you know what? I'm gonna go get a ZoomLock. I'm gonna get the ZoomLock filter dryer, and we'll save a lot of steps here. All right, I'm gonna head to the shop. I'm gonna get a 3/8 bi-directional press compatible filter dryer with two 3/8 ZoomLock couplings, and we're going to get this job done in record-breaking time. If I can eliminate the torch, I could eliminate nitrogen. I eliminate a lot of steps that we normally have to take. It is 8:27 here on Friday, the 14th of August. Let's go! All right, I'm gonna close off the service valves at the outdoor unit. That way I don't have to recover all the refrigerant. Oh, and now I remember why, one of the reasons of several, why we stopped installing the Bosch IDS is because you can't use a regular service wrench on the service valves. Ain't that so stupid? Really? You can't use a regular service wrench, like that ratcheting wrench there from Yellow Jacket, on their service valves. You have to close them and open them like this. Tell me how dumb that is. Crazy. Absolutely crazy. Nuts. Hold on. I can't. This is just pissing me off. You know, and that hole right there was a little bit bigger. You know, in some of those Yorks, you have that hole in the bottom of the electrical cabinet where you can put your Allen key in there and open and close the service valves, those king valves. Sorry, king valves. Service valves, whatever. I'm just now like not happy. Not happy that our filter dryer is leaking, but whatever. Once we head back inside, I'm going to talk about why there are filter dryers in systems and what makes them important, and why ACiQ systems don't have them. So make sure you stick around and watch me struggle with this stupid freaking valve that God knows how much further it's going to go before it pisses me off, and I'm really going to get mad. I'm going to beat this thing with a stick. Beat it with a stick. Pretend it's like a redneck from Oregon, living in a double wide, double stacked trailer. Yep, you know what I'm talking about. Yeah, double wide, double stacked. I'll tell you what, one thing that's not like this, ACiQ. Their systems are awesome. Side discharge, inverter driven compressors, fully communicating. Oh, I keep hitting my elbow on that piece of stucco on the, oh, I scraped my elbow. Imagine this is like digging a hole to China. It came from China. All right. Come on, baby, we're almost there. Oh, finally. All right. I could also pump down to the condensing coil. Yeah, maybe I should have done that. Okay. I cut one side. Here's that bi-directional filter dryer. It's gonna go right around there. Let's mark this right there. Okay. All right, ladies and gentlemen, we found the problem. Right here on that 3/8 refrigerant line, we have a bi-directional filter dryer, and it's leaking. So before I cut this out and replace it, it's actually a perfect opportunity to explain what this filter dryer does, why it's here, and why you don't see the same setup on some newer inverter systems like the ACiQ Extreme. So a lot of homeowners see this little canister like this and probably have absolutely no idea what it does. But this little guy here is very, very important. The filter dryer basically has two jobs. Number one, as the name explains, filtering. It's there to catch very small solid contaminants that shouldn't be circulating through the refrigeration system. Things like copper oxide, debris from installation, particles from the compressor, or other contamination. You got very small passages inside metering devices that you don't want to have garbage getting into a TXV, restricting the refrigerant flow. Number two, drying. Inside this bad boy right here is this material that it's designed to absorb moisture. And moisture is one of the absolute enemies of a refrigeration system. Why? Well, because moisture combined with refrigerant and compressor oil can contribute to acid formation, oil breakdown, corrosion restrictions, and ultimately compressor damage. So we want the refrigeration circuit clean, dry, and tight. And that's why when we braze, we nitrogen purge. That's why we pull a deep, proper vacuum. That's why we use micron gauges, and that's why filter dryers exist. Now, this is a bi-directional filter dryer, and that's because this system is a heat pump. On traditional, conventional straight cooling air conditioning systems, refrigerant essentially travels in one direction, from the liquid line in one normal operating direction. But a heat pump has this thing called a reversing valve. When we switch between heating and cooling, the direction of refrigerant flow changes. So we need a filter dryer that's designed for flow in both directions. We can't just grab any directional liquid line filter dryer off the truck and stick it on a heat pump system. We have to install a component designed for the application. There's our failure. We're going to cut this out and I'm going to show you. All right, let's deburr the pipe. Beautiful. All right, and then the other right there. Beautiful. All right. Oh, thank goodness the homeowner had spare AAA batteries, because I went to turn on the micron gauge. Oh, hope that was tight. Went to go turn on the Blueback Plus micron gauge, and it's dead. Figures. And that other one, still not reading anything. Navic. Piece of shit. I don't know. Thought I threw that one out. Look at that. Absolutely nothing on that. Nothing. Biggest piece of shit. Navic. the micron gauge. Cool. All right, I want to speed up the vacuuming process, the evacuation of refrigerant in the system. So I hooked up the other vacuum hose to my vacuum pump. And we're going to pull a vacuum. So hopefully there's no leaks in the system. I did not run any nitrogen. I probably should have, but I have not. So it is 9:17. Oh, there we go. Look at that. Beautiful. Love it. All right, this could take a few minutes, like 15, 20. It could take an hour. This is the one part of the process you don't want to rush at all. But let's take a look at what happens here. The refrigeration system itself didn't necessarily fail. A component in the refrigeration circuit developed a leak. And one tiny refrigerant leak means no cooling, lost refrigerant, and an unhappy homeowner. So today we went flameless. Instead of putting in another and brazing in another filter dryer like this one, we put in that ZoomLock filter dryer. ZoomLock by Parker Sporlin. It's amazing. I think this is one of the first times we're actually using a ZoomLock filter dryer, but I wanted to eliminate the torch, the flame, and the associated components that go with that, like purging with nitrogen and what have you. So we prepped the copper, we deburred the pipe, we use open mesh paper to clean off, you know, the outside of the tubing, and I was able to press that in literally under 60 seconds. And that saves time. If you save time, you save money. And plus, I happen to like, I think it's very clean workmanship. All right, I'm preparing my jug of R410A. It's inverted. You always charge R410A in a liquid, so you have to invert the container. My scale is zeroed out. Let's purge out the oxygen, the air, all those non-condensables. Once I start seeing a little bit of vapor, close that. So now our charging hose is full of liquid refrigerant. We're still at around 0 pounds. Awesome. We're at 506 microns, 505, 504, and dropping. We're going to let this get down. It's only been about 10 minutes. So let's give that some more time. We're at 500 microns right now. Beautiful. 499. Okay, let me get rid of what I can get rid of to save some time, and hit you back in a minute. One question I get asked quite frequently is, why don't we install an external liquid line filter dryer on an ACiQ Extreme system, but we do on a Bosch inverter heat pump? Well, the answer is quite simple. Manufacturer design and requirements. The ACiQ Extreme Plus is engineered more like a ducted mini-split system. The refrigeration circuit, electronic expansion controls, and factory filtration are designed as an integrated package. ACiQ does not call for us to add on a conventional field-installed liquid line filter dryer, so we don't add another restriction to the system that it wasn't designed for. And that's straight from ACiQ. Bosch takes a different approach. On its IDS heat pump systems, Bosch specifically recommends a properly sized liquid line filter dryer as part of the home installation. And that's quoted from Bosch Home Comfort website. So this isn't just about one system being better protected than the other. It's about RTFM, following the manufacturer's recommendations of reading the factory manual regarding the refrigeration circuit as it's manufacturer engineered. ACiQ, don't add it unless they specify it. Bosch, install it because Bosch requires it. Remember this, folks, RTFM, read the factory manual. Always follow the installation manual, and don't be a habit of not. All right, I got my system down pretty low, 425 microns. Let's open up this valve. We're gonna release that charge that's inside the condensing coil into the 3/8 line. That's gonna start traveling through the 3/8 line towards that new filter dryer, towards on the evaporator coil, and back on that 7/8 line. So I'm going to open this up, and then I'm going to quickly close the other side. So whatever refrigerant we had in there is now traveling out of the condensing unit Good. Now, let's take that off. That's that refrigerant we see there. Look at this. Why? Why? Look at this. There's nothing in there, but it's reading 1900 microns. What is up with this? Why is it reading that? Come on. Why? Why? Why is it like this? Can someone please explain this to me? I really don't get it. Come on. Why is it like this? And that's why I don't trust these things unless you spend a boatload of money on them and they're less than 1 season old. Look at that. Why is it reading? Finally, high pressure. Oh, God, I don't get it. I really don't get it. I know. Stick with plumbing, right? All right, right now I'm just rapidly dumping refrigerant into the refrigeration circuit. We're already at 2 pounds already. 2.2, 2.4, 2.5. This factory charge is close to 11, and that's probably what we're going to need, close to that amount. Right now I'm slowly opening up that main valve on that 7/8 suction line. I'm going to stop that at 5 pounds because I don't want to overcharge the system, God forbid, but we'll stop at 5 pounds. It's right around there. Perfect. I'm going to keep opening up this valve. I apologize for the noise. Hose A and Hose B are here with their weed whackers. You better not hit me, bro. We'll be fighting. I'll spare you. It's quite interesting how the progression of how we installed systems over the years has changed. You know, that unit over there was the last system that we installed here, and you'll see we have an ICM 518 surge protection device on that big blue brick right there, and on the other ones we're using the Rector Seal, and how now we're using our own device that I source together with parts and I build them. So I'm doing power range monitoring, basically like power conditioning with surge protection, and it's awesome. You know, the MP SPD01 surge protection device and power monitor. It's quite awesome, and I offer them as a donation gift when the community supports my nonprofit, the Mikey Pipes Philanthropy charitable organization. For more details, go to pipesforfree.org on that. I turned the power back on by plugging in the disconnect there. That made a noise. The light is on, flashing. There's a time delay. There is an active call for cooling, so as soon as that is, as soon as this is time delay is over, that'll get power, and then we should have cooling in a few minutes. All right, we just got power to our inverter control board, reading 79 degrees of ambient temperature. I'm going to move quick now because I just removed the vacuum hoses and I'm putting the cores back in. Perfect, no leaks. Awesome. Let's get our probes back on, just like we had them before. Okay, 0 PSI. Let's get that probe on there. Come on, baby. We need to add a lot more refrigerant, so I'm moving quick. There you go, there's that one there. It's already running. Let's move quicker. Let's move quicker, folks. I'm gonna go to the app. All right, let's see. We're at 8 pounds. This is what everything looks like. A little low on that subcooling. Target is closer to 10. Our inverter. Let's force the system into high speed. All right. We're going to ramp up the inverter to high speed. That T, that sideways T you see right there. And we're going to see what our readings are then with the inverter running at 100%. That's showing the frequency. Right now it's showing 59, 60, 61. I'm sorry you can't see it on the screen, the flickering, the frequency between the camera and the frequency of the LED display, but We have a 16.5 degree superheat with no subcooling. That unit's kicking on right now. Only add a little more refrigerant to the system. There was hardly any refrigerant in the system. The factory charge is that 11 pounds, 5 ounces on a 5-ton BOVA 60. Sorry, BOVB 60. We're gonna go to 9 pounds, just on gut instinct and experience. But we're probably approaching the end of our supply in that tank. I did bring a spare 25-gallon tank when I went to the shop to got the ZoomLock and then the ZoomLock Filter-Drier. So I'm just gonna dump whatever remaining charge is in this container into the system and then see what our conditions are like. Good old Bosch. .7. All right, second container of R410A. I just purged the air out of the hose. We're still at 61 hertz, full speed, 100% inverter performance. Taking a look at our pressures. Our subcooling is still low. Bosch says don't worry about superheat. Subcooling is at 1.6, 1.5. It's been that way for about 10 minutes, 15 minutes now. So we're gonna add some more refrigerant. That was 8 pounds. And we'll see how much more we gotta add here. Looking for that target subcooling to be around 10. All right, ladies and gentlemen, 10:10 in the morning. Take a look at our pressures, 116 and 290. Subcooling of 9.4 degrees. And we used a lot of refrigerant. A lot. This bad boy is basically empty. Total calculated weigh-in at 11.5 pounds of R410A. Damn, these hold a lot of refrigerant. A lot of refrigerant. But the system is cooling very, very well. She is beer can cold and she is condensing like damn, like there's no tomorrow. Absolutely love it. Absolutely love it. We're still at that high speed, that forced cool mode at 61 hertz on the inverter frequency, and she is cooking. Woo! 60,000 BTUs of cooling at its finest right here. I think the only thing better than this would be an ACiQ, but I gotta tell you, I really love the Bosch 5-ton system because it's still quiet considering the tonnage of the system. It's top discharge, but the ACiQ 5-ton system is a double stacked outdoor unit. It's big, it's tall. And I've done multiple 5-ton systems with the ACiQ Extreme Plus, but if I'm gonna put a 5-ton system in and money's no object, I'm gonna go with the Bosch. I wouldn't dare go with a Carrier Infinity because that's just wasteful money. That's just stupid money. But a 5-ton, me personally, I would still go with a Bosch. As much as I love ACiQ, it's a Bosch, folks. But at the end of the day, guess what? They're both made by Medea. Straight up. This right there, made at the same plant in China that makes ACiQ. Same company makes Bosch. Now, ACiQ does make top discharge heat pump inverters as well, though. I don't deal with those. I like the side discharge because I like the color combination, but I gotta tell you, I'm not looking forward to the day that these start to go, but I know that I'll be the contractor to take care of these systems when they start to die. And I just hope it's not the Carrier, because that's the most difficult air handler in the face of the world to get to. He may have to take off the roof when we have to do that next time around. But hopefully that's in many, 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 many years. And we already placed an evaporator coil, so. Oh! Thanks for watching, guys. Catch you in the next one. Be well, God bless, stay safe. And remember, if you want to be an ACiQ dealer, head on over to aciq.com/MikeyPipes. Tell them I sent you. On that first order you give them, you're going to get a crazy bonus. So crazy that you're going to want to personally reach out to me. Don't touch me. Don't do it. But you want to walk up the fly to New York and thank me and take me out for dinner. Because that first order that you place with ACiQ, you're going to get on your hands and knees like this. Like, oh, thank you, St. Mike. Thank you. Thank you for hooking me up with ACiQ like hundreds of other contractors are doing right now. All right, ladies and gentlemen. Thank you again so much for tuning in. Really appreciate it. Hope you enjoyed this video. Hope you got something out of it. Hope you learned something. If you are in the Long Island, New York City metropolitan area and you're tired of getting bamboozled by your HVAC contractor, you know what to do. Pick up the phone, give us a call, 516-348-6300. Or save time. Book online at pipedoc.net. That's PIPEDOC.net. Thank you again. Until next time, be well, God bless, stay safe, and may God bless America.